Hello dear students, hope you're doing well. So today we have section 3 of chapter 2. We'll be talking about scientific measurements, how to take measurements, how to calculate stuff in chemistry, and how to deal with scientific notation, significant figures, and a lot other stuff, because this is a very long section, so be careful to not binge it all in one sitting. Try to specify time for you in order for you to understand it better. So first we have the difference between accuracy and precision. Accuracy is the closeness of measurements to the correct or the accepted value. Whenever you're doing an experiment, theoretically we should get a specific number, okay? Then we will do our experiment, we will get another number. This might not be equal to the one that we theoretically should have, okay? So the more the one that we got is closer to the ideal one, or the perfect score, or the accepted value that we should have, the better accuracy we have in our measurements, okay? On the other hand, precision is when you're doing an experiment, you're doing it more than once in order to be precise. What do you mean by precise? Meaning that when you do it more than once, the values should be close to each other. The numbers, for example, you get, let's say you calculate mass, you get 3.1, then you get 3, and the third one you get, let's say 3.15. Look, all of them are close to each other, meaning you have precision, okay? So accuracy, you're comparing the one that you got to the true value or the accepted value that you should have. Precision, you're comparing all the things that you got or the measurements that you got to each other, if they're close to each other or not, okay? Let's take some examples. If you do this, let's say the dart or whatever you call it, this game, the accepted value or our aim is in the middle, right? We should get all of our darts here, right? So this is our true value. Look, all of them are exactly on the true value, meaning that we have high accuracy. Precision, we also have high precision. Why? Because all of our answers are close to each other, okay? The second one, we have high precision. Why? Because all of our answers are close to each other, but they should be here, right? This is our true value. They are away from here, meaning that we have low accuracy. The third one, it's neither. So they're not close to the true value or to each other. They're away from each other, meaning we have low precision and low accuracy. The last one, the answers, they're close to the true value. So we have high accuracy, but they're not close to each other, meaning we have low precision. This is the difference between accuracy and precision. Next, we have percentage error. As we said, we have a true value, right? Our answer should be close to this true value that we should have. The more closer the answer is to the true value, the better our work outcome is. So how would you know? We calculate percent error. So the percentage in which will tell us whether we did our job correctly or not. Okay, how do you calculate it? We have this rule in which we subtract two numbers. We have the value of the accepted value minus the experimental value. The accepted value, this is theoretically, the question will give it to you, okay? So this is the true value. The other one, the experimental value, is the one that you do it experimentally. You're doing your experiment, you have an answer, this is you, okay? Divided by, again, the one that the question has given it to you, the accepted value. You multiply it by 100, you get the percentage at the end, okay? Sometimes this percentage is positive, other times it's negative. What does that mean? When we have the accepted value, if it is bigger than the experimental value, meaning that the theoretical one, the question that has given us, is more than the one you calculate, you will have a positive value, positive percentage. If the accepted value is less than the experimental value, the one that you do, the percentage error will be negative. Okay, so it depends. Let's go to sample problem. A student measures the mass and the volume of a substance and calculates its density. So we have the density, which is this one. The correct or accepted value of the density should be this one. So theoretically, we should get 1.36. The student has got 1.40, not 1.36. So what is the percentage error, okay, of the student's measurement? What do you do? Write down what you have from the question, then the rule, then answer it, okay? So what do we have from the question? The accepted value, theoretical value, should be 1.36. The one that you did, the experimental value, it was 1.40. Percentage error is unknown. So calculate it. This is your rule. You follow it, you get the answer, okay? You got negative 2.94% error. Practice number 1. What is the percentage error? Again, percentage error is unknown for a mass of measurement of 17.7, given that the correct value is 21.2. So this is the correct value or accepted value, and this is the one you did, experimental value. Then calculate percentage again. Use the rule, subtract them, divided by 21.2, which is the accepted value. Then you get an answer, which is 16.5, close to 17 if you round it. The second one, the volume is measured experimentally as this. What is the percentage error? Given that the correct value, so accepted value, is 4.15 milliliters. How much you got? 4.26 milliliters. Calculate percentage. Again, write down the rule, subtract them, then divide it, multiply by 100, you got negative 2.7%. The trick here is to know the difference between the accepted value and the theoretical value. Read your question carefully, then write down what you have from the question, just like here. Write down the rule and follow it. It's easy. It will be easy. Okay, most of the time our measurements that we do, they are not perfect, they are not 100% accurate. That's why we have percentage error in each experiment. These errors, they're because of some reasons. These are few of them. Number one is the skill of the person doing the measurement. They're not 100%, could not be 100% precise. Number two, the conditions of the experiment. Sometimes if, let's say, the temperature changes, some variables, they do change as well, such as the density. So you should have all conditions constant, otherwise it will not go correctly. Number three, the measuring instrument. Sometimes we have errors in instruments itself, so you have to calibrate it, so make it to 0.0, then do your experiment or use the device. Okay, next we have significant figures. What do you mean by significant figures? Significant figures or numbers in our experiment, they consist of all the known digits with certainty plus one final one which is uncertain. What does that mean? Whenever we have a number, a measurement, the last number on your right, it's always estimated, and the rest, they are sure figures or sure numbers. Okay, we have some rules to follow. How would you know how many significant? For example, for this question or this example, we have 3 significant figures. How did I know? Okay, we have rules to follow. This is the table. You should understand it. Do not memorize it, just understand it, or follow this one that I did. Rule number 1 is that all numbers are significant other than 0. For example, from 1 to 9, all of them, they are significant other than 0. So we have a problem with 0. If it is between two numbers, it is significant. Let's say we have 206. So all numbers are significant? Yes, yes. 0 is in between two numbers, so yes. How many significant figures do we have? 3. Okay. Rule number 3, if your 0 is on the left side of the number or of the decimal, it's never significant. Let's say we have 0.0023. Look, zeros on your left side of the numbers, they're not significant. This is a number, this is a number, so yes, yes. How many do we have? Only 2, okay? Because 0 is on your left. Number 4, 0 on your right, we have 2 possibilities. If you have the decimal, it will be significant. If you do not have the decimal, it's not significant. Let's say we have 200.10 and we have 20,010. Okay, what's the difference between these two numbers? Here we have the decimal, here we do not have the decimal. Okay, so here this number, they're significant. 2 zeros between two numbers, significant. Now we have the 0, we have a problem. Do we have the decimal? Yes, so this is also significant. So how many do we have here? 5 significant figures. Look at here. Numbers significant. Zeros between numbers significant. The one on your right, the 0. Do we have the decimal? No, so it's not significant. Okay, so here we only have 4 significant figures. Okay, you can we'll take some examples, then you'll know, and you will differentiate between it. The general rule for 0: if it is between two numbers, it is significant. If it is on your left, it's never significant, the left side of numbers. If it is on your right, we have 2 options. Do you have the decimal? Yes, it is significant. We do not have the decimal, so no, it's not significant. Let's take some examples. So we have this number. All of them are numbers. We do not have a problem with them, so all of them are significant. 3 significant figures. Here, we have numbers, 0. Do we have the decimal? It's on your right? Yes, so it is significant. 4 significant figures. Here, look, number, 0. Do we have the decimal? No, so it's not significant. Only 2. 0 on your left, they're never significant. Number. This 0 is between two numbers, so yes. 4 significant figures. Here, on your left, never. Number. 0 is on your right. Do we have the decimal? Yes. So yes. 5 significant figures. Okay. Practice number 1. This number. Look at here. Number. The 0 is in between two numbers. Yes. Between two numbers. Yes. So 5 significant figures. Here, on your left, no. Number. 0 between two numbers. Yes. 0 on your right. Look, do you have the decimal? Yes. So yes. 6 significant figures. Number. 0 between two numbers. Yes. Number. 0 on your right. Do you have the decimal? No. So no. So only 1. Here, number, yes. We have zeros on your right. Do we have the decimal? Yes. 1, 2, 3, 4. So 5 significant figures. Here, on your left, no. Number. 0 on your right. Do we have the decimal? Yes. So yes. 6 significant figures. And the second question, suppose the value 7,000 centimeters is reported to you. How should the number be expressed if it is intended to contain the following significant figures? If you only want one significant figure, just write 7,000 normally, because these zeros, they do not count. We do not have the decimal, so yes. 4 significant figures, all of them, so you should have a decimal, so 7,000 with a dot, with a decimal. 6 significant figures, we have 7,000.00, still 7,000, but how many significant figures? Okay, 6. Next we have rounding. How can we round a specific number to a specific number of significant figures? First of all, these are the rules that you should follow. So number 1, if you have a number greater than 5, it gives 1 point to the number right beside it. For example, if we have, let's say, 42.68, okay, we want to round it. How many significant figures do we have? 1, 2, 3, and 4. If you want to round it into only 3 significant figures, okay, only 3 significant figures, so 1, 2, 3. What do? Just underline it. Then after this, what do you have? 8. Is it more than 5? Yes. So it gives 1 point to this 6, becoming 42.7. Okay. Number 2, if it is less than 5, just ignore it. If, for example, we had 42.64, okay, again, we want to round it into 3 significant figures. 1, 2, 3. Then round, okay? Because this is less than 5, come on, just ignore it. So the answer should be 42.6. Number 3, if 5 after this 5 or less than 5, if you have 5, if it is followed by a non-zero digit, you will increase it by 1, okay? So let's take an example. If we have, for example, let's say 2.7851, if you want to round it into, again, 3 significant figures, okay? So 1, 2, 3. We have this 5. Do you have a number after it? Yes. If this number is not a 0, so yes, you can round it. You can give 1 point to this 8, becoming 2.79, okay? Another example, or the other rule, if 5 is not followed by a non-zero digit and it's an odd number, what do? You increase it by 1. If it's an even number, it stays the same, so nothing happens. So the difference between these examples, let's take 2 examples and compare them, okay? What's the difference between them? Why one of them is increased by 1, the other one is not increased by 1. So let's say we have 4.635. We want to round it into 3 significant figures, okay? We have this 5, it's not followed by anything. Then what happens to it? So this gives 1 point to this 3, becoming 4. So 4.64. Okay, this is example number 1. Example number 2, if we have something like this, 78.65. Again, you want to round it into 3 significant figures. This 5, you want to round it, right? So it's nothing is following this 5. And number right beside it, it's an even number. In the other example, we had an odd number. That's why you increase it by 1. This is an even number, so you do nothing. So it stays the same, 0.6. So you just ignore this 5. When we add or subtract 2 numbers, what should we do? We have to be careful with number of decimal places. What do you mean? For example, if we have, let's say, 6.35, decimal places are on your right side. Okay, so this is your decimal. How many numbers do we have after this decimal? 2 numbers. It means we have 2 decimal places. Okay, when we add or subtract 2 numbers, you should have the same number of decimal places. Let's say we have 25.1, so 1 decimal place, so 1 number after the decimal. The other one is 2.03. We have 2 decimal places. What do? We have to round them into both of them having only 1 decimal place. So this is 1, this is 2. Both of them should have 1. What do? Look, 25.1 plus 2.03. Up until here, they're the same thing, right? What do? Round this. So this is less than 5, right? So you just ignore it, becoming 25.1 plus 2.0, and normally add them. So this is your answer. Okay, so you just have to be careful with the number of decimal places. Let's say we have this. Do we have decimals? No. So when we do not have decimals, it's not a problem, right? But we have another problem. We have to be careful with number of significant figures. Okay, here we only have 2 significant figures. Here we have 3 significant figures. Okay, so what do you do into both of them to be close to each other? And when you add them, you get an answer of having only 2 significant figures. You round this because this has more significant figures than this. So take this as a rule. You round the one with more significant figures into having same number of significant figures and the other one. So 365, you round it, becoming 400, then add them together. When you multiply or divide numbers, again, you have to be careful with significant figures. So let's say we divide these two numbers together. The first one has 3 significant figures. The second one also 3. So the answer should have 3 significant figures. If you divide these two numbers, you will have this huge number. How many significant figures do you have? Many significant figures. We only want how many? 3, because both of them have 3 significant figures. Okay, so you round it. So you go, the 0 does not count because it's on your left, it's not significant. 1, 2, 3. What comes after it, round it, it's 0, so just ignore it and ignore the rest. Okay, so the answer should be 0.360 grams per milliliters. Let's go to the sample problem. A, you subtract these two numbers. Again, write them down. Up until here, they have the same number of decimal places. Then the extra one, not this, ignore this, the one right beside it, round it, it's less than 5, so just ignore the rest. Then normally subtract them. You know how to subtract two numbers. When you multiply, same thing, just look at the significant figures. The answer should have the least number of significant figures. So here we have 2, here we have 4, choose the small number, meaning that the answer should be only 2 significant figures. You multiply them, use the calculator, you get this huge number. We have 5 significant figures, we only need 2. So 1, 2, what comes after it? 9, you round it, so it gives 1 point to this 7, becoming 8. Practice, what is the sum of this number and this number? So you just add them again, write them down. Up until here, they are the same thing. Then just round it. This is more than 5, so it gives 1 point to this 6. Then normally add these two numbers together. Same thing goes here. Calculate the quantity of this minus this. Up until here, they're the same thing. We have this 5, we have an even number, so it gives 1 point to this, becoming 7. And normally add them. Question 3, calculate the area of a rectangle. The area of rectangle, the rule is length times width. Okay, so you have two numbers, length, we have width, you just multiply them. Okay, but be careful with the significant figures again. Here we have 3 significant figures, here we have 4. Choose the small number, meaning 3, so the answer should be 3. You multiply them, getting this huge answer. We need only 3 significant figures, so 1, 2, 3. What comes after it? 3, so less than 5, just ignore the rest, becoming 1.00. Question 4, we have polycarbonate plastic. The density is this much. A photo frame is constructed from 2 3.0 millimeter sheets. Okay. Each sheet measures 28 centimeters, but do not forget we have 2 of them, which are 3 millimeters. The measurements, there are 28 centimeters by 22. Okay, write down what you have. So what is unknown masses? And write down what you have. Density. We have 2 sheets. You add them, meaning we have 3 milliliters and 3 milliliters, which is 6 milliliters. Change it into centimeter. Why? Because the other measurements are in centimeters. Okay, they should have the same unit. So we have 0.6 centimeters. Then the volume is, just multiply your 3 numbers. We have 3 measurements, just multiply them. So 0.6 times 28 times 22. The answer is this. Okay, then this is your volume. We do not need volume from the question. Question is saying we need mass. Mass is unknown. Okay, density is mass over volume. So what do? Cross multiply. So mass is equal to density times volume. You multiply 2 numbers. But again, at the end, be careful with the significant figures. Here we have 2, here we have 4, meaning you choose this, so the small number. The answer should be only 2. Round it into having 2. This is less than 5, so just ignore it. So 440 grams. Next we have scientific notation. What do you mean by scientific notation? In order for our calculations for them to be easy for us to understand, we express them not in small numbers, not in huge numbers. So a moderate number, which is scientific notation. How do you express it? We have m, which is the number, mantissa. This should be between 1 and 10, more and equal to 1, but less than 10. 10 not included. You cannot use 10 as mantissa. You can use from 1 up to 9.9, okay? And multiplied by 10 to the power of something. So we have the exponent. This should be a whole number. You cannot say, let's say, 10 to the power of 1 over 2. No, should be, let's say, 2, for example, or negative 2 is also allowed, but fraction, no. For example, we have this huge number. What do? You change it into scientific notation. How? Look, we do not have the decimal, so the decimal is at the end. We should have a mantissa between 1 and 10, right? So what do? You move your decimal up until you get a number between 1 and 10. So this is 1, 2 times, 3 times. I moved it 4 times, I got 6.5. Because I moved it 4 times, to the left, it's positive 4. So 6.5 times 10 to the power of positive 4. If you have this small number, what do? Move your decimal. This is your decimal. Move it to the right, okay? How many times we moved it? 4 times. We got 1.2, which is the mantissa, which is correct. You moved it to the right, so it's negative 4, okay? So to the left, it's positive. To the right, it's negative. The power of 10 or the exponent. If you have scientific notation, you add them, you subtract them. What should you do? How would you do it? Both of them, when you add or subtract two numbers with powers, both of them should have the same 10 to the power, or 10 with same exponents. Okay, so here we have 10 to the power of 4, here we have 10 to the power of 3. It's not allowed for someone just to normally add these two numbers. No, both of them should have the same power. So change this into having the same power. We can change this 10 to the power of 3 into becoming 4. How? Move your decimal to the left if you want to add a point to this. Move it to the right if you want to subtract a point to this. Okay, so 3, it wants to become 4. Move it to the left. It becomes 0.79 times 10 to the power of 4. So now both of them have the same power. You can just normally add these two numbers, not powers, no, numbers together. When you add them, both of them have 10 to the power of 4, so just write it down at the end once. And normally add these two numbers, you get the answer. Okay? When you multiply, it's not the same thing. When you add, so both of add or subtract, both of them should have the same power. But when you multiply or divide, same thing goes for division. When you multiply, you add the two powers together and normally multiply the numbers. Okay, so you just multiply these two numbers. The powers here we had 6 and here we had negative 2. You add them, meaning 6 plus negative 2, meaning 6 minus 2, meaning 4. For division, when you divide two numbers, you subtract powers. You do not add them, you subtract them. So when you multiply, you add them, okay? When you divide, you subtract them. So we say 10 to the power of 7, here we have 10 to the power of 4, so 7 minus 4 becoming 3, and normally do your calculations. So normally divide these two numbers, but for powers just subtract them. So what were the steps when we wanted, for example, to, let's say, calculate density for something, or we had a sample problem or practice, we want to calculate something? What do? We have steps to follow. Step number 1, you have to analyze it. You have to read the question carefully at least twice, then analyze it. What do we have from the question? What does it need from you to do? Then identify the given and the unknown. Always write down what is given from the question and what is unknown. Step number 2, plan it. Now we have what is given and what is unknown. What is the relationship between these two? For example, if you have density given, let's say 1.2, you want volume. What's the relationship between them? What rule do we have that connects both of them together? We say density is mass per volume. So we have both of them. You can just normally calculate it. Okay, so write it down, the equation, and sometimes use conversion factors and stuff, for example, to change from a unit to another unit. Third step is to compute, meaning you have to write down what you have for, let's say here, write down what you have for mass, write down what you have for volume or for density to calculate the unknown. So write them down, cancel units to get the final answer. The last step, which is very important, which is evaluating. What does that mean? Meaning you have to think about your answer. Does it make sense or not? These are some things to check at the end. Number one, check to see if we have correct units. Let's say for density, you got cubic centimeters. Cubic centimeters is not the unit for density, so you did something incorrectly. It should be, for example, grams per cubic centimeters, not centimeters. Okay. Number two, make an estimate of the expected answer. Let's say something is doubling, the answer should also be doubled, but at the end, it was less than the original answer, so it's not correct. We have to think and be sure that the answer is expressed always to the correct number of significant figures. When we talked about it, when we add or subtract numbers, be careful, they should have the same powers. Or when we divide or multiply two numbers, we have to be careful with the significant figures. Okay, this was it for section 3. It was a bit long, that's why it was in 2 parts. I will see you guys later.